Thanks for tuning in at Brackies.
Hello everyone and welcome to video number 8 on making a multiplayer FPS in Unity. In today's video we're gonna have a look at respawning our player whenever his health amount reaches 0. Today we're just gonna lay the basic mechanics out there, and then later we can have a look at making it look really awesome. So today's all gonna be about coding this functionality and syncing it over the network. So before we get started, I of course want to say that if you have any questions, go to forum.brackies.com. And if you want to support me in making these videos, well then you can do so at brackies.com/donate. Any support is greatly appreciated. So that's basically all I want to plug, and now we can just open up Unity and get started. So the first thing that we want to do here is go to the player object, and I just want to fix a quick bug from a previous video, which is that our mask here stating what we can actually hit when we shoot is currently set to everything, and the point of this is that it should actually filter out our local player, so I want to remove that from the list. We were lucky that this actually worked because we were shooting rays from inside the collider, and therefore Unity weren't registering the hits, but this should be way more stable if you should decide to move the collider or whatever. So great, and we can just save that. So now we can go ahead and open up this player script in Visual Studio or Mono Developer, whatever you're using. And remember, the player script hosts this current health variable, and that's a sync var, meaning that the state of this variable will be synced across all connected clients. And it also has this take damage method. But this is just an ordinary method. So how is it called? Well, if we open up our player shoot script, which is only enabled on local clients, that's the player setup that takes care of that. You can see here that if we get a button, then it calls this shoot method on the client. And this simply checks if what we hit was a player and all that. And if it was, it calls a method on the server saying that a player was shot. And you can see this is marked as a command in order to make Unity understand that this was on the server. And you can say that it throws a debug.log here that will only be shown on the host, of course. And it finds the player and calls the take damage method. So the take damage is only currently called on the server, or at least by the server. But the state of the variable is synced to all other objects using the sync var. But I kind of want to change this because we want to have other methods have other functionality inside the take damage method, such as checking if we've died or not, and if we have calling a method that actually displays this, and we want to do that on all clients, not only the server. And therefore I want to change this from an ordinary method into what is called an RPC call. And client RPCs are used to make sure that a method is called on all different clients. So that's really cool. And let's try and do this in code. So it's actually really easy. Just as we are able to mark a method as a command by simply writing command here, we can mark it as an RPC call by simply writing client RPC. And now, as soon as this take damage method is called, it will make sure to do so on all computers connected to the network. And just as we have to prefix it with a CMD here, we now have to prefix it with a RPC. So it's now called RPC take damage. And inside of Visual Studio, if you want to change the name of all references, you can just press Ctrl RR, and then we can say RPC take damage and hit enter, and now we can see in the player shoot here that it's changed it there also. So that's just a handy shortcut. You can of course go ahead and do that yourself. That's called refactoring. What we can do now is introduce a boolean which will say whether or not the player is currently alive or whether or not he's dead. So let's make a private bool underscore is dead, and we'll default that to false. Then we'll make an accessor for this, so a public bool, a property here, is dead, And we want to have both a getter and a setter, but I want the setter to be protected. So get here will return underscore is dead. So anything that has a reference to the instance can check if it's dead. But the setter here, I don't want to just write set, I want to write protected set. And this makes sure that only the player class or classes that derive from the player class are able to actually change this variable. So this will say is dead equals value. Cool. And now we can sync, we can sync this is dead variable. So we'll just mark this as a sync var. And of course, this is the exact same as saying public bool is dead, and then simply doing get protected set like this. But when you write it out like this, you cannot mark a property as a sync var. So that's why we have to do the other thing there. Cool. And now down here in the RPC take damage, we can basically check that, well, we only want to take damage if we are not dead. So if is dead, well, then we just want to return. Good. And then down here, we can check if current health is less than or equal to 0. So if we've indeed died, well, then we want to call some kind of die method. Awesome. So that's the very foundation of how we will handle checking whether or not we've died. And now we can make this private void die. Because I want this to only be called through the take damage method. So if you want the player to instantly die, well, then we'll just damage him by a very large amount. And in here we'll set is dead equal to true. And then we want to disable some components on the player object. This will make sure that he cannot move anymore, he cannot be collided with, and maybe we'll also disable some renderers in that. This is not going to look very cool right now because we're not going to be changing settings on the rigid body or instantiating particles or anything like that. We're just going to make this functional for now. And then we'll throw a debug.log statement saying that transform.name is dead. Like that. That should be dramatic enough. And then we want to call some kind of respawn method. So call respawn method. So we kind of just have to fill in these holes now. And I think we can pretty much just go ahead and do that. So yeah, why not? Okay, so let's first have a look at disabling the components here. So basically how I want to kind of sketch this out is I had this idea that we would have an array of behaviors of components. So we can simply drag them in the inspector what we want to disable whenever the player dies. And then at the very beginning of the game, we'll check which of these components are enabled on the client, because some components might be enabled for the local host or the local player, but not for other instances. And therefore we need to check which components are enabled and store that, whether or not they were enabled, in a Boolean array. And then when we respawn, we simply go through all of the components that we disabled and set them equal to the corresponding Boolean in the Boolean array. So if that sounds very vague, that's fine. We're just going to sketch it out here. So first off, I want to make a serialized field, because I do want this to be private. And that's simply going to be a behavior array. And disable on death is what I'm going to call this. And then we'll make a private bool array here called was enabled. So you can see here that for any given index, we are going to have a component and whether or not it was originally enabled. then we are also going to change this from an awake function into something else, but we'll have a look at that in a second. So actually, let's do this now. So we want to change this into a setup method, and instead of having this called through the start of the awake, we want to have this called whenever the player setup is ready, because whenever we are checking whether or not a component is enabled, we need to do that after we've enabled or disabled components in the player setup script, and therefore we could put a yield wait for a certain amount of seconds statement in here, and that would time it up. But I think it would be better to simply tie these together and have the player setup call a setup method on the player here. So we're going to make this a public void called setup, and for now it's simply going to call this set defaults method. But I want to go through here and set the was enabled equal to a new Boolean array. And the length of this is going to be the disabled on death array's length here. So those are going to be the same. And then we can simply loop through this. By the way, if you write 4 and then hit tab, 4 and then hit tab here twice, that will allow you to simply use a template for the for statement. So I want this to be I, and I want this to be was enabled dot length, and then enter, and there you go. So that's a very easy way of creating for statements. And then we simply say was enabled to the ith increment equals disable on death I dot enabled. So we just loop through all of the different components and store whether or not they're enabled in this Boolean array. And because we are not going to be reordering any of these arrays, we can do it just like this. If we were going to reorder stuff, we might need to have a dictionary in here or something else, but this is going to work just fine. And then we go on to setting the defaults here. And I'm going to want to have a look at the defaults method. So in here, we of course want to set isDead equal to false. We're also going to want to say for, and again, we can use this shortcut here. So int I equals 0, and then disable on death dot length. So we want to loop through that. And we simply want to say that disable on death to I dot enabled equals was enabled, again the ith position here. So here we are doing the exact opposite of what we just did. We are saying that we want to loop through all of the components, and we want to set the enable state equal to whether or not they were originally disabled or enabled. So we are basically just reversing the process there. I also want to have a special case for the collider, but because it turns out Unity has defined this idea of behaviors. You can see up here that this is a network behavior. A network behavior derives from mono behavior, which derives from behavior. And a behavior is just a component, as stated by Unity, that can be disabled or enabled. However, Unity's colliders can both be enabled and disabled, but they are not actually derived from behavior. They are just derived from component, which behavior also derives from, but components cannot be enabled or disabled, but colliders can. So we cannot actually store a collider in this behavior array, and therefore I just want to create a special case, sort of say, for this collider. And I want to make sure that if we don't have a collider, well, then it's just going to ignore it. So we're going to say here collider call equals get component of type collider. And this will work, of course, with any collider. And then we check if collider is not equal to null. So if we actually have a collider, well, then we want to enable it here. So enabled equals true. And this is of course going to work for our instance and most instances. If you have a collider and only a single one sitting on the game object where the player is, this is going to work. If you have multiple colliders or don't want it to be enabled from the start or anything like that, then you're going to have to write some more code. But this should give you an idea of how to do that. You can create a similar array using colliders instead of behaviors and do the exact same thing. Cool. So that should set our defaults just right. So now in the die method, we can go ahead and loop through these and disable them. So for, and again, I'll use this shortcut here. Oops. And this is going to be I. And the length here is going to be disable on death.length once again. Cool. And then we can simply say that disable on death, the ith element dot enabled equals false. Simply loop through all of them and disable them. And then we're again gonna kind of copy this down here. Simply gonna get the collider component, check whether or not it's null, and if it's not null, well then we want to disable it. Awesome. And we write out the debug.log statement, and now we are actually ready to call the respawn method, because right now it should actually be working. However, once we die, we don't respawn. But that's fine. I mean, so let's try and set this up first. So let's just make sure that we actually call this setup method. So if we go into our player setup script, you can see here that in the start function, we check whether or not we're a local player, disable some components, assign a remote layer, do some stuff with the scene camera, which we are later going to move out of this because it doesn't quite belong. And well, then down here, once all of that is finished, we're actually ready to call the method. And you can see that we already require the component with type player. So we're basically able to just make the assumption that it's there and say get component player dot setup. If I'm actually able to type this out. I just got a new keyboard, so bear with me here. Alright, so now we are calling that method. Everything seems good. Whenever you have to do with networking and making sure that all of these things are calling each other on the right clients and all that, it requires a lot of debugging. So if this actually works, I will be the happiest person on earth. So let's just go ahead and make room for two components here. And the first one is going to be the player controller to make sure that we won't move. So if we just completely disable our player input, well then of course we'll stop moving. The second one here is going to be the player shoot script. There we go. And it will automatically disable the collider. And I think that should pretty much be it. I mean, you can go ahead and drag in stuff like the network transform and all of that, but I don't think it's going to be necessary. This should disable the most necessary components. Alright. And I'll also go ahead and leave the max health at 100, but I think I want to just make our weapon a bit more effective here. So instead of a damage of 10, let's do a damage of 40. Cool. And yeah, so in order to actually try this out, we could go ahead and just build it all the time and then start shooting players. But I'm going to show you a very quick way to just check if this is actually working. So in our update method, we are just going to check if we are the local player, and if we are not local player, well then we're going to return. We just want this to call on the local player for now. And in here we're simply going to check if we get a key down with the key code, and the key we're going to check for is the K kill for kill. K key for kill. And then we want to call the RPC take damage. There we go. This is gonna oops. And of course we need to give it a huge amount here, so just a bunch of 9s there. So now we can simply press the K key, and that will simulate us being shot So if we go in here under the LAN host, hit K, you can see that I'm unable to move now. If we go under the player object here, player controller is disabled, player shoot is disabled. If we go in here, up here, and change this to debug, we should be able to see that is dead is now true, and our current health is a huge negative number here. And you can also inspect the disable on death here, and the was enabled. So you can see that both player controller and player shoot was enabled at the very beginning. And that's true, because this is the local host, so of course they were enabled. But if other player, or if we viewed a connected clients instance of this player, these would be false, both of them. So that's why we have to have this in here. So now we can jump out of debug mode again. And I think we are ready to code the actual respawning now. So in order to do this, what we want to do here is we want to call a respawn method. And we'll do this by using an IEnumerator, because we want to wait a certain amount of seconds, and therefore they're really smart, and we've done this before, at least in other videos. So if we haven't done it here, this is how you do it. So up here we want to be using system.collections. And don't ask me why, that's just something that we're going to do. Then down here, we can make an IEnumerator, and this is a method like any other. This is a return type, just like writing void, but it just looks very scary, but in reality it's very easy to use. I will call this respawn, and it's not going to take in any arguments here, and we're just going to mark that as private, not that it matters. And then we're going to write, and right after me, yield return new wait 4 seconds, and this is with all caps. And then we want to wait a certain amount of seconds. For now we're just going to wait 3 seconds. And then we want to start the respawning, so we are going to set our default values. Then we're going to find a start point that we want to spawn at. So we're going to create a transform start point here, and that's going to find the network manager .singleton, which is the instance of the network manager in our scene. And we should maybe do some checking here whether or not it's actually there and all that. But let's just go ahead and do write this out. So singleton dot and then get start position, and that will return one of the spawn points in the registered in the network manager. So now we can simply say that transform.position equals start point dot position. Actually, I'm going to rename this to spawn point. I think that's more clean. And again, look here, I use the double control RR in order to rename all the variables. And then we want to set transform.rotation equal to spawn point.rotation also. So that should actually respawn our player, and now all we need to do up here is call it. So you might go ahead and do respawn like this, but that's not actually valid. What we need to do instead is we need to call the start coroutine. And for some reason that's bugging out, so the start coroutine. And then in here we put the respawn method. So that's what we want to start, and then a semicolon, and there we go. So that should basically be all. And this should be working now, so let's just test it out. Hit play here. Select host. Let's just move out here. Kill ourselves, so now we can't move. You can see it says player 1 is dead. And there we go, we respawned. So let's just make a debug.log statement in the respawn too. So down here, we'll say debug.log player respawned. We'll give it the name too. So transform.name plus respawned. Great. And the last thing here is respawn time is a pretty important value for pretty much any FPS. And therefore, hard coding it in here would be kind of stupid, especially if you wanted to later say, let the players control how long it's going to take to respawn. So let's instead create a class that will store important settings for our match. So let's define a new class here, create C# script called match settings. I will just double click that, reload all here. And it's not going to be using neither Unity engine or system.collections, and it's not going to derive from anything. For now, it's actually only going to store a public float spawn or respawn delay, respawn time, and we are just going to set that equal to 3 seconds for now. The only thing that I want to do here is I want to mark this as a system.serializable, and that will allow us to use it correctly, and it will allow us to make sure to change these values inside of the Unity inspector when we embed it into another class, which we're going to do now. So we're going to open up the game manager, and this is going to host or this is going to have a variable storing the match settings. For now, we've just used this for registering the player here, so kind of keeping track of different players. And we are going to be using the game manager for multiple stuff, but in order to not clutter this completely and have a very long script, I'm just going to quickly define a region here. So if you write hashtag region, and then you write the name of the region, and this is just player tracking or player registering or whatever you want to do. I'm just going to call this player tracking. And then down here we want to end the region. Then we can actually here collapse that. And that's really cool. So now we have this collapsible kind of part of the script, and that makes it very easy to kind of get an overview of your scripts. I do this all the time when I write longer scripts, because sometimes it's just useful to have a lot of functionality in one place, and then regions pretty much save my life. Without those, getting an overview of what you're doing would be so difficult. So now we can kind of create the other part of the game manager here, and it's going to store a public match settings, and it's just going to be called match settings here. And we're going to be configuring this in the inspector, so I don't want to set it equal to something. And of course, the game manager here, there only exists one in the scene at any given time, and therefore it would be kind of a good idea to turn this into somewhat of a singleton pattern. So a singleton pattern, I don't think I've talked about this yet, but it basically allows us to only have one instance of something running at any time. And we're not going to have any control on this, but we are going to store a static reference to that instance. So if that sounds very weird to you, don't worry. It's super easy to set up the singleton idea. This is going to be a very, very cheatsy, easy way of doing a singleton, but it's actually going to work just fine. So we're going to define this public static game manager variable, and this is going to be the instance. Some call it singleton, as you saw. Here the network manager calls it singleton, network manager.singleton. Others just do ints. Yeah, I've seen a lot of different stuff here, but I like instance. It's very clean, I think, and it describes what it does. And then inside of the awake method here, we simply set instance equal to this. And we can check if there's another object in the scene. So if instance is not equal to null, that means that something else has set this up before us. And that means that we have another game manager in the scene. So we want to write out an error here saying debug.log error. more than one game manager in scene. And if not, well, then we can set the instance variable here. Good. So that will make sure that we can always very easily get a reference to the game manager without having to do GameObject.find or anything like that. So when we now head into our player script, we can go up here and even create a reference to this up here. If we want to do that. That might even be stupid. I think it's even too much to do that. Instead, we are simply going to go down into the respawn method here, and then we are going to say game manager dot instance dot match settings dot respawn time. There we go. So it's simply going to find the game manager that we have in our scene, access the match settings, access the respawn time value. And that should be all, hopefully. So now I think we can just comment out this update method here. That was just for testing. So there we go, comment that out. By the way, in order to comment out, actually I changed that shortcut. Yeah, I don't know, but you can comment out a lot of stuff by making a multi-line comment like that if you want to. Oops. Alright, so let's save that and let's try just clearing out the console here. There we go. Let's try building this. There we go. And whenever we build the player, we have to wait for Unity to update the lighting here, and it has done so now. Like that. So we can maybe make this the host and connect this as a client. And I'm just going to go down here and I'm going to shoot our host. You can see it says he's dead and he respawns. And you can see it's very jittery, and the reason why is that it tries to smooth his position when he's teleported to the right spawn point. But we're not going to be worrying about this because, well, frankly, we don't have anything to show that he's currently dead. That's in a later video. And you can see he can now move around again. So we can shoot this guy. It says he's dead. You can see he can't move. We respawn and now we can move again. So that's basically it for respawning, and this should work pretty well. Yep. So that's all for this video. I hope you enjoyed it, and I'll see you in the next one.